One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, we're back and we're talking about detox and toxicity. Actually, more properly, we're talking about testing as it relates to things like detoxification. And in the last episode, I went through just a brief description of the hierarchy of detoxification. And that would be talking about detox as it relates to liver enzyme systems, what we call phase 1 detox, phase 2 detox, which is a liver-based conjugation system where toxins get transformed by enzymes and then have things added to them to make them mixable with water so you can excrete them. Talk about the importance of glutathione as not just an antioxidant, but as a natural chelator that can bind to toxins, including things like heavy metals and environmental chemicals to get rid of them. And the final thing was chemical tolerance. And we didn't spend too much time talking on that. It's a really big issue, really big topic. We'll say a few more things about it in this particular episode, but suffice it to say for the moment that you should be able to tolerate your environment. I mean, certainly the environment is filled with things that are unnatural, things that didn't exist 100 years ago. We're making new chemicals all the time. And as I mentioned, I believe in the opener in the last episode, we're dumping hundreds of tons of chemicals into the environment every year. And there are no laws, at least right now, that means that chemicals or companies that make chemicals have to prove that they're safe before they get released into the environment to do whatever it is they're going to do. And so this concept of immune tolerance is actually very tightly tied to tolerance of your own tissue, your body, as well as tolerance to your diet. And so quite often what we see when people have environmental sensitivities or what we might call multiple chemical sensitivities is that they quite often also have autoimmunities and they have food sensitivities. And so tolerance, when we look at that as a feature of the immune system, basically is the capacity to not react to something. So you don't want your body reacting to yourself. If it does, then we call that autoimmunity, where the immune system attacks some part of your body. We don't want you reacting to your diet. The proteins in your diet should be allowed to enter into the system, get processed, and then incorporated into different structures and used for different functions. And when we lose tolerance to our diet or dietary proteins, we call that food allergy or food sensitivity. And then finally, again, we should tolerate the environment. But I'll tell you, and I think we have to go back just a little bit. What I want to end up talking about today is talking about the two types of testing that are relevant in and around this idea of toxins. And we have to make a sharp delineation between the nature of the two tests. And we'll come back to this, but just very briefly, sometimes we're concerned about how much of something you have in your system. And remember, it's not a question of, do you have toxins? Are you toxic? You are. That's just the fact of life these days. The question is, how much of certain things do you have? And that's a quantitative question. But the other side of that coin is more of a qualitative question, and that is whether or not your immune system is involved in reacting to your environment. And we'll come back because there might be some nuances, and I just want to get some major thoughts out there, and then you can do some more digging on your own. We'll end up talking about these issues and these topics a little bit more as the podcast continues on, because inevitably these topics come up in different scenarios and different contexts. But let's start with talking about the quantitative part of this question. How toxic are you? And so when we look at the field of functional medicine, natural medicine in the broader sense, and what typically gets practiced is if somebody comes into an office of a natural practitioner and the idea of toxicity comes up, that clinician or practitioner might want to do blood testing, hair testing, stool testing, trying to find how much of X, Y, and Z is in your body. And a lot of times there's, focus specifically on things like heavy metals, particularly mercury, just because, it can be really bad, but it can also be very well tolerated. But my point is this, is that most docs are locked into thinking only with one half of the coin, and that is how much of something do you have in your body? And that's a valid question because we certainly know that the impact of heavy metals and other types of toxins like environmental chemicals has a dose dependent relationship. So, yes, how much of something you has matters. And in general, the higher levels of something you have, we can draw a couple of conclusions. Number one, more than likely, it's impacting your physiology to a greater degree. If we could cut that level in half, then maybe the impact would be cut in half as well. And so, yeah, how much matters? Quantity matters. But there's another aspect of quantity as well, which is the more chemical load you have, whether that is multiple toxins or whether it is higher amounts of specific ones or a combination of those, the more likely you are to overwhelm your natural detox capacity as mediated through phase 1, phase 2 liver systems, but also the potential to deplete your glutathione stores. Because remember, glutathione is not just an antioxidant that protects your cells from things like oxidative stress or free radicals. It is a chelator. And you think of it like a sponge. There's a point where you've mopped up so much water with your sponge that you can't take any more. You have to squeeze it out, dry it out a little bit before you can mop up more with that same sponge. And glutathione, because we have a limited capacity to make it, assuming we're not taking it in supplement form or doing something like IV therapy, there's only so much glutathione that you have to go around. And if your glutathione is being used up because it's trying to neutralize an elevated, quantitatively higher toxin load, then you have less glutathione to contribute to other things, whether that is dampening inflammation and the potential to cause damage to your cells, or whether it is glutathione's contribution to things like your barrier systems. Like we know we have studies that show that you don't get leaky gut, for example, until the intracellular glutathione levels of your intestinal epithelial cells gets down below a certain threshold. So you kind of have to be glutathione deficient to have a permeability issue, like a leaky gut or perhaps a leaky brain. And again, if you're using up your glutathione, dealing with this environmental insult, then you just don't have enough glutathione to do all the things that glutathione should be doing for you. And so, yeah, quantity matters. We want to know what toxins are you burdened with and which one of those are higher than we expect. Now, higher than we expect or higher than normal is a very subjective, it's a subjective statement. And understand that historically, and I'm going to be paraphrasing and just painting broad pictures. So I mean, you can pick apart the way that I present this, and that's okay. But I'm just trying to convey an issue or concepts to you, and I may not get things historically perfectly accurate, and I hope you're okay with that. But in general, historically, when toxicity levels have been studied, they do it somehow like this. For example, let's say I'm a scientist and I have a compound X that I'm trying to determine what the safe dose is or what the toxicity level is in humans. Well, I'm not going to do human studies because no one's going to volunteer to be injected with toxins to figure out what level makes you really sick or kills you, right? So, unfortunately, this is where things like animal testing comes in. And so again, I'm a scientist theoretically, and I'm doing toxicity testing on compound X. And so I get 10 different rabbits, for example, or mice, and I inject each successive rabbit with a slightly higher level than the one before. So rabbit 1 gets a little teeny tiny dose. Rabbit 2 gets a little bit more. Rabbit 3 gets more than rabbits 1 and 2, and so on, all the way up to rabbit number 10, which gets the highest dose in this particular study. And basically the way toxicity testing and study has been done to determine what the safe levels are for humans and human exposure would be to go back and look at the 10 animals that were injected and look at which ones are sick and which ones die. And the ones that are still alive theoretically represent the ones that got safe doses. And so, for example, if rabbits 8, 9, and 10 died, then the human equivalent of the dose for number 7 all the way down to number 1 is what we consider or would be considered safe. Now, there has to be some kind of a calculation because these laboratory animals have different metabolic rates than humans do. And so there, has to be kind of an equivalent dosing calculation that's been done. But nevertheless, that's generally how safe doses of these toxins are determined. Well, there's a whole bunch of problems with that I don't know it's really worthwhile for us to really explore. But here's what I want to point out to you is that there may not be safe levels of toxins, particularly when you start to look at chronic exposure. And it's a big difference between injecting somebody with a small amount of compound X, that's a toxin, that's considered generally safe, and you look to see if that person is sick or dead within a period of a couple of days, versus someone who gets exposed to a low level of compound X for 20 years or 30 years. And we don't have those studies, not that I'm aware of anyways, and certainly they could exist. I can't read every journal and every article that comes out there, but theoretically, we have gaps in our data, and we have a lack of understanding of chronic and long-term exposure of what is generally considered safe for human consumption or for human exposure. And so, yeah, quantity matters, but when it comes to looking at labs that present these reference ranges where theoretically numbers below a certain cutoff point are considered okay and safe, we have to put a question mark on that, because not only do we question maybe the methodology of how do we determine what is safe and what is not safe, there's no way that these toxicity studies can account for individual variability. Because maybe I have really robust glutathione levels. Maybe my liver phase 1, phase 2 systems work well, and I have no interfering factors like genetic polymorphisms in my cytochrome P450 system. Maybe I don't have any thyroid issues. Maybe you do. And maybe your ability to convert toxins into a water mixable form to get rid of them is compromised. Maybe you've got a microbiome disturbances. Maybe you're chronically constipated and you're not moving your bowels and getting rid of things. And so toxins are recirculating throughout the body. Maybe you've been dealing with more stress, more infections. Maybe you have autoimmunity and your glutathione levels are depleted. And so you don't have that natural chelating neutralization capacity that I do. And what that means is that a dose that I tolerate, you don't. And so looking at whether or not something is elevated on a quantitative test, and that's really what we're talking about. Like, how impressed are you that you get a toxin test back and everything is normal? Well, in some cases, maybe you're very impressed. Like, hey, high five, this is great. Maybe that doesn't make any difference, and here's why. The other side of the coin is not quantitative, it's qualitative. It has to do with the context of whole health and all the things that go into whether or not somebody can handle the chemicals in their environment, including whether or not their immune system is involved. And so you can have two people who have normal quantitative test results. Let's say that I run two clients and I submit blood samples, for example, looking at urinary mycotoxins or environmental chemicals, even heavy metals. And let's say that not only is every marker normal, but quantitatively the results are identical. They all have the same levels of all the different types of things that we can test for. That doesn't mean both of them are going to be okay with that. Again, for reasons that I just went through, context of biochemical individuality really makes a big difference. But even more so, you can have a normal amount of any given toxin. I'll just pick on mercury because it's the easiest one to pick on. Let's say that your mercury levels are normal. However, if your immune system is reacting to mercury in your body, then that's a big deal. That's a huge deal. And that's more important than whether or not you have a quantitatively normal level of mercury or any other toxin, because your immune system's involved. And what that means is that despite having a normal level, which theoretically should be okay for you, once your immune system gets involved and we start to break down tolerance, and that's what it means to have your immune system involved, then we open ourselves to a whole host of other problems. One, because the systemic inflammatory cascade that comes from environmental reactivity, having lost tolerance to the environment that you live in and things that are outside of your body and things that are inside your body from a toxin standpoint, wears down other systems. It contributes to things like leaky gut, leaky brain. It drives mitochondrial dysfunction. It drives neuroinflammation. It impairs insulin sensitivity. It dysregulates your hormonal system, or systems, plural, and so on, and so on, and so on. But here's the deal. your immune system can only react to things that have protein structures. And the last time I checked, mercury is not a protein. It doesn't have amino acids. Neither do chemicals like bisphenol A or dry cleaning elements or solvents or paint thinners. They don't have protein structures. So how is it that your immune system can react to something that doesn't have a protein structure when it can only react to things that have protein structure? Well, here's the answer. And the answer comes to us in the world of environmental immune testing. And that is that things like heavy metals and environmental chemicals have the capacity to bind to proteins in your body. So they, you can be exposed. Again, I'm just picking on mercury because it's easy. Mercury comes in, and for some people, particularly those who don't detoxify and chelate well, for some people, mercury, other toxins, binds to their own tissues. And now your immune system can react to not just the mercury, for example, but the mercury that's bound to your own tissues. And if it just so happens that mercury is binding to your thyroid, then your immune system starts to attack your thyroid. And this is an environmentally mediated model of things like Hashimoto's disease or perhaps Graves' disease. Hashimoto's is certainly more common. If, for example, you have an environmental chemical that is binding to the proteins in the cartilage in your joints, and your immune system starts to react to that, now you have an environmentally mediated loss of tolerance that is driving things like rheumatoid arthritis. And we can play that game, whether it's type 1 diabetes, your pancreas and insulin, whether it is myelin basic protein and things like multiple sclerosis. It doesn't matter what the tissue target is. The point that I'm making is that for some people who don't handle their environment well, tend to lose tolerance to things that come in from the outside. And even though they might be quantitatively normal, they have a qualitative response from the immune system to the toxin bound to your own tissues. And this is what the literature calls a tilt syndrome. This is a toxicant-induced loss of tolerance. That's what TILT, T-I-L-T, stands for. And this has been in the literature for something like 15 years or so. We've been teaching this in functional medicine seminars for at least 10 years that I can remember. But when researchers came up with this model that explains why the environment and environmental sensitivity can drive autoimmunity, it was like a huge revelation. Because every single practitioner I've ever spoken to has had the experience of deciding to run some kind of a toxin test, expecting to see quantitative elevations, but not seeing them, yet being convinced that the environment was still involved in someone's, say, autoimmune expression. And the only way we can explain that is, number one, either the test was wrong and there's more in their system than what they believe to be, or more likely, what's happening is that the immune system is responding to a toxin or a chemical, even though it is within the normal reference range and should be tolerated by their physiology. And that's what was never accounted for in the early days of research in terms of toxicity testing and defining what these normal reference ranges were. That was never accounted for. They didn't account for biochemical individuality, and they didn't account for this concept of loss of tolerance because we didn't understand it back then. Now we do. Now we have a much more clear picture of why some people have toxicity issues, even when their toxin levels are normal. And again, so just to boil it down and maybe close this particular episode, when you're thinking about, am I toxic and should I test for it? You have to ask two questions. Number one is, what is my toxin load? Again, that's a quantitative test. And I'm not going to get into whether or not you should be doing hair analysis or blood testing or stool testing. There are pros and cons, and some of those, particularly things like blood testing and stool testing, have far more research and validation than, for example, things like hair testing. I'm not a fan of that myself. But my point is this: if you are considering, hey, do I need testing in and around the idea of toxicity? Number one, you want a quantitative analysis that's going to give you some reliable information, but you can't stop there. Particularly if in your life, I react when I smell perfumes or gas, or I get exposed to harsh household cleaners. It creates symptoms. It drives my inflammation. It drives my autoimmunity. If you know that that's happening, then you have to explore the other side of that equation, which is whether or not your immune system is involved. And yes, one of my favorite labs, Cyrex Labs, actually has a test for this. It's called Array Number 11, and it is a chemical immune reactivity screen, and it checks for immune responses to common types of heavy metals and different environmental chemicals that are bound to human tissues. Remember, your immune system cannot react to a heavy metal. It cannot react to a chemical, but these things can bind to your own tissues, and then you can react to the complex of those two things connected together. Having said that, when your immune system reacts to the complex of those two things together, what we call a neoantigen, it doesn't react to the metal or the chemical, it reacts to the human tissue protein portion, which is where the autoimmunity from the environment comes from. Now, it's only one of many different ways you can have autoimmunity, but let's call this episode a wrap. And just stay tuned, because a couple more things that I want to talk about as it relates to toxicity that you might find interest. Well, as always, thanks for being here. You can check me out on all the different social media channels. Please remember to comment, rate, like. It's how we spread the word and get this whole idea of we're a nation and a collective. We're all struggling with things like inflammation to different degrees. So let's help each other out and spread the word. We'll see you in the next episode.